All right, so in this video, I'm going to show you how to dry an organic solution and also how to filter that drying agent out. And so this will, I'm going to show you two ways to filter, and that will, filtering is just a way to separate a solid from a liquid. And you've probably done something like this at home. I mean, really, if you think about it, like if you make pasta, right? So you've got all this boiled pasta in water, you pour it through a strainer. Pasta can't go through the strainer, so it stays in the strainer. The water goes through, and you've separated them. So you've filtered before. There's lots of different ways of doing it. I'll show you kind of how we do it in this lab. So there's the general and the specific. And so in all of these videos, you should pay attention to what is general and what is specific. Okay, so 10 years from now, you're in a lab, you need to filter something. How this hood looks, what's in the drawers won't mean anything to you, but the general principles will still apply. Okay, so I've got here two flasks. These are both solutions of ethyl acetate. There's obviously something yellow in them. We'll work with those here in a minute. So the first thing to know, right? You've seen the extraction video. You've thought about these things. Ethyl acetate is not soluble in water. It's not completely soluble in water. It forms two layers, but traces of water will dissolve in ethyl acetate. Traces of ethyl acetate will dissolve in water. There are very few substances where we can say there's just absolutely no solubility. So we would like to get rid of the last traces of water here. And what we're going to do is we're going to use a drying agent. And a drying agent is just something that absorbs water. All right, so we're going to use anhydrous sodium sulfate. Sodium sulfate can be hydrated. I think it can hold up to 6 waters. And so if we put the anhydrous in, all right, so we're just going to open it up. Don't use too much. I'm just going to kind of take a spatula full like that, add it to the flask. All right, then I'm going to stir that up. All right, sodium sulfate's an ionic solid. It's not going to dissolve in a relatively nonpolar solvent like ethyl acetate. How are we doing here? So you can see there's solid there in the bottom, right? And the question I often get asked, and it's actually a good question, is how do you know when you've added enough? And what will happen is if there's water in the solvent, the solid will clump. You've probably seen this before, right? If you've ever added, I don't know, baking soda to an aqueous solution, it'll start to clump up before it dissolves. So if there's a little bit of water in there, it will clump up. And what you want to do is keep adding sodium sulfate until at least some of it spins free and doesn't change form. So sodium sulfate's kind of powdery. I've added enough now that there's a clump in there. I don't think you can see it on camera, but most of the sodium sulfate looks powdery. All right, there's no water for it to clump up with, and the same's true in this other one. And that's actually, the reason I didn't have to add much sodium sulfate this time, because I didn't actually get these solutions from an extraction. I got these solutions just by pouring solvent in there, so there's not much water in it already. In the extraction, you might need to add more. All right, well, obviously, we don't want sodium sulfate in there. We ultimately want to isolate whatever this yellow compound is. And that's I'm going to show in another video with the rotovap. So how do I now get this sodium sulfate out? Well, I filter it. So there are two ways to filter it. The first I'm going to show is gravity filtration. And that's just what you've done with pasta at home, right? You just pour it through a filter of some sort. So I'm going to need another flask. All right, you want to make sure it's clean. That's not clean. All right, I'm going to take this label off. No, I'm not, because it's really on there. All right, take the label off because somebody left it labeled from last year's lab. And then I need a funnel. So, just explore your drawers when you first come into lab. And then I'm going to for gravity filtration, I'm going to take this kind of big piece of filter paper and I'm going to flute it. So I'm going to fold it in half. Fold it in half once. Fold it in half twice, like kind of feel like I'm doing a magic trick. And then you just kind of fold it. I'm terrible at this. You just fold it in fractions after it's quartered. Generally get 4 fractions out of that. You have something that looks like that. And now, when you open it up, it's conical. All right, it'll sit down. It'll sit down in the funnel. Is that on camera? Yeah, so it will sit down in the funnel like that, like so. All right, and now I'm going to take my sodium sulfate suspension. I'm going to just hold this down, and I'm going to carefully pour through here. You want to make sure you don't pour too fast, that the solvent like overflows the flask. And there you go. Like you see, a lot of the sodium sulfate has stayed in there. Always work with solvent in the hood. I'm going to rinse this just a little bit. You don't have to rinse a lot. You don't want to rinse a lot. You don't want to use too much solvent because you have to remove the solvent. That takes some time. But I'm going to put some more in there. One rinse is always a good idea. I'm going to let this kind of drip a little bit. All right, see it dripping there. Put you back over here. All right, so now I'm going to pour the last bit of this. If you swirl right before you pour, you'll get a lot of that solid out. You don't have to get all this solid out. Remember, you're trying to separate the solid, so if some solid stays behind, that's fine. All right, I'm going to set this aside. So that's gravity filtration. Now, the second way to filter is vacuum filtration. So there, in gravity filtration, I hope it's obvious, the reason the liquid is going through the filter paper is gravity. Always reliable. For vacuum filtration, we're going to suck the liquid through. So now I need, never can find it. Now we need what's called a vacuum flask. All right, so a vacuum Erlenmeyer is just going to have this sidearm where we can attach a hose and pull a vacuum. We also need a Buechner funnel. All right, it's just a porcelain funnel. It's got some tiny little holes in it. This is not useful for gravity filtration. Okay, and we also need a neoprene adapter like this. So neoprene adapter is going to fit around the stem of the Buechner funnel, and then that's going to fit in the top of the vacuum flask. And then if you look, is it, hopefully it's there. Well, all right, so every hood's going to have 2 of these. The flask says, please do not disassemble or remove, so leave this in your hood. I'm going to need to clamp this somehow. So I'm going to move, I'm going to take this I'm going to take this stand, put it here. I'm going to pull out a clamp. So these little clamp holders, screw that turns. We can put a clamp in there. Don't be afraid to play in the lab a little bit. Don't do anything dangerous. Don't light a match or anything. That's not what I mean by play, but kind of explore and see what there is. And, you want to get comfortable with the lab area. All right, so now one of these I've clamped on the, I've tightened the screw on the clamp, and now with the second screw I can put it on the stand. Yep. All right, so now I've clamped this Erlenmeyer, the vacuum flask, onto the ring stand. I'm going to take this tube and attach it to the side arm. All right, don't force anything. Don't use a lot of force. So there, I don't know if you can see this. I'll bring it over close. All right, so this is, right, so there you see how it's attached. That hose goes on the side arm, neoprene adapter between the flask and the Buchner funnel. All right, we're going to need one more thing here. We're going to need some filter paper. So I'm going to open up. The filter paper has to exactly fit. Right, smaller filter paper exactly fits the Buchner funnel. All right, so pour that out. Just pop it back in. All right, so it's flat. You don't need to flute the paper that goes. In fact, you should not flute the paper that goes into the Buchner funnel. So now, how do I get a vacuum here? So when you come in the lab, notice that each lab we have some electrical outlets. We have a fume hood here, right? We can raise this, but you typically won't. We have a sash that we can close. The hood, there's exhaust. If you look at the top of Salem Hall, we replace the air in Salem Hall about 4 times an hour. Like, it's constantly going, but 4 building volumes of air an hour. And the reason for that is the building's full of chemicals. If we didn't have airflow like this, the building would reek. Okay, so that's why you work in the fume hood. All these volatile solvents, the fumes are being pulled out up through the stack on the top of the building. Okay, so there's also these 4 knobs. One is air. Listen. All right, that's compressed air that will shoot out of the orange handle. There's, maybe you see it there in the back. All right, that's the green handle. Cold water. Don't drink that. It's not potable. Read the sign. There's compressed gas. There's nothing hooked up to that. So that, we could hook a nitrogen line up or an argon line up, and that would give us an inert gas to work with. The handle you'll want is vacuum. All right, so I'm going to turn the vacuum, and that's going to, all right, so that, I should have pointed it out. Sorry, I will bring this back over. All right, so you've got a hose hooked up to the yellow line. That's the vacuum. You've got a hose hooked up to the orange line. That's the air. All right. So the hose goes from the yellow spigot up to that Erlenmeyer flask up there, and that's just a trap, right? We're going to pull a vacuum here. We don't want stuff to get into this line and then get into our house vacuum line. So by having that trap flask there, anything that accidentally gets pulled into this will get trapped in that flask. All right, that's probably more explanation than you really need. Okay, so I'm going to go ahead and start the vacuum. So we're applying differential pressure to glass. All right, glass can shatter. This is why a lab coat is important. This is why safety glasses are important. I'm going to kind of apply gentle pressure there, pull that down. And then the other thing I'm going to do is put a little bit of the solvent that I'm filtering with on the filter paper. All right, this will just kind of wet it down, make it adhere a little bit to the Buchner funnel. I'm going to swirl this flask up. Now I'm going to pour it onto the filter paper, and the vacuum is going to pull the liquid through. This will go a lot faster than the gravity filtration did. All right, look at that. Bang, bang. So now all that solvent is down below. Again, I'm going to do a rinse. One rinse. You don't have to rinse forever. You don't need tons. There we go. Right, now once I've filtered and it's done, I'm going to remove the hose first. Always remove the hose before you turn the vacuum off. All right, if I turn the vacuum off, I've got a vacuum pulled, and it can pull stuff back out of the house vac. It can pull solvent from there. So remove the hose first, turn the house vac off. There you go. All right. Always hold the flask. So there's my filtered sodium sulfate. Put that there. And there's my solution of dry ethyl acetate and yellow something. All right. Here's the gravity filter. Same thing, if you look. Right, there's a little color here still, and you're like, oh, I lost material. Things that are colored, dyes and whatnot, are colored at very low concentrations. There's no more than 1 milligram of material in this filter paper. But you can see, right, if you look, we probably lost more material in the gravity filtration than we did in the vacuum filtration. All things being equal, I would rather do the vacuum filtration takes a little longer to set up. You get more dirty glassware. Gravity filtration takes longer to filter and isn't quite as efficient. All right, in the next video, I'm going to show you how you use a rotovap to remove the solvent from whatever the yellow stuff is.